Okay, we're looking back at our lunch tray scenario, and we are going to calculate how much upward force Barry is having to exert to keep the tray balanced. So Barry is carrying his tray of food. The length is 0.5 meters long. So the length of the tray itself is 0.5 meters long, which I've written out here for you. And it has a mass of 0.2 kilograms. So the mass of the tray is 0.2 kilograms. And it's holding a plate, which is 0.4 kilograms. So the total mass there is 0.4 kilograms plus the 0.2 kilograms. That total mass is 0.6. Mass equals 0.6 kilograms, right? And then he's holding the plate. It is 0.2 meters from the edge of the tray. Okay, so it's not from the fulcrum, it's from the edge of the tray. But what we need to consider in any kind of torque calculations is the distance from the fulcrum. So it says his thumb is the fulcrum, so we need to find this distance here. Because we know the end distance, but we need to know the distance from his thumb to the plate. So we know the whole length is 0.5 meters. And we know that from the plate to the edge, it's 0.2. So if we do a simple subtraction problem, 0.5 minus 0.2, we get 0.3 meters. So our distance for the plate is 0.3 meters. All right. Now, I'm going to go ahead and erase this. Now Barry's holding the tray by by the edge with one hand, using his thumb as the fulcrum, and it's pushing up. His fingers are pushing up at 0.1 meters from the fulcrum. Okay, so we know that distance there. How much upward force is his fingertips exerting to keep the tray level? So basically what we're saying is that torque down has to equal torque up. Okay, in order to keep it balanced, torque down has to equal torque up. Well, we don't, so first we have to figure out how much torque the plate is applying. So to figure out torque, again, the formula for torque is torque equals force times distance. Well, we weren't given force, but we were given mass. And force equals mass times acceleration. And that acceleration, downward acceleration, is going to be due to gravity. So anytime we're trying to find weight of something, it's mass times acceleration due to gravity. So we're going to take our 0.6 kilograms and multiply that by 9.8 meters per second squared to get the force that we're going to need. So we've got 0.6, let's clear this out, 0.6 times 9.8, 5.88. So our force downward equals 5.88 newtons. Okay, now we have everything we need to solve for our downward torque. So we want to solve for downward torque. We need to get force times the distance. We have force times the distance. So let's figure out our downward torque. Is the 5.88 newtons times 9 point, not 9.8, sorry, that, times our distance, 0.3, let's try that again. 1.76. Okay, so I've figured out the first part for you. Now I want you to figure out the upward force. Okay, so we know that torque down has to equal torque up. So your torque down here is going to get plugged into here because your torque up is the same. That 1.76 Newton meters. Down. And so it's also going to be, since it's balanced, it's also going to be 1.76 Newton meters up. So you're going to plug in 1.76 and divide it from the distance where the upward force is. So that's 0.1. So you're going to take that 1.76 and divide it by the 0.1. Go ahead and solve that and let me know. Did he have to apply more force or less force than the force were to go down?